All right, so last night we had homework problem 41, and we've gone through how to do that whole problem in its entirety by hand. But now I want to show you how you could do that entire problem on your calculator. And for your quiz tomorrow, you'll have your graphing calculator, so you'll have your choice. Do you want to do it by hand like we did last night, or do you want to do the whole thing on your calculator like I'm about to show you? And then the same thing on the review homework, you can use your calculator, and on the test, you can do this whole thing on your calculator. So entirely up to you, whichever way you like better. So let's go through it together. All right, to begin with, if I'm going to put these inequalities in my calculator, I'm going to need to solve them for y, right? So we've got y is greater than 0. That one's good already. X plus y is less than or equal to 250, so let's subtract the x from both sides. And then for this guy, I'm going to subtract 250x from both sides, and then I'm going to divide both sides by 400, okay? So once I've got those inequalities, then I want to go to the Inequalities app that I linked you. So go ahead and open that Inequalities application. Once you turn it on, you should not need to turn it on again. It should already be open and available to you when you go to y equals. All right, so let's go to y equals, and we want to put those inequalities in. We played around with this the other day, but let's do that again. All right, so when we go to y equals, we can put in those inequalities. So remember, the way that we do that is if you have your cursor positioned on top of the equal sign, then you'll get all these other options that typically you would not have. And if you'll notice over here, like equal to is above F1, less than is above F2, less than equal to is above F3, greater than is above F4, and greater than equal to is above F5. So for the first equation, y was greater than or equal to 0, since we wanted greater than equal to, all I had to do was hit alpha and then hit F5, and it put that greater than equal to in. You can see if I did like alpha F3, then it would switch it, just kidding, try that again. If I do alpha F3, then it would switch it to less than equal to. And notice it automatically then switched to shading down below. It knows where to shade based on the inequality. So again, I wanted that to be greater than equal to, and that's the F5, so I'm going to do alpha F5 to get that greater than equal to. All right, so once we have our three inequalities in y, remember that we had that one inequality that was x is greater than or equal to 0? This is so cool. See this guy right here? X equals. If you'll use your cursor and you'll arrow up, just like you would arrow up to those stat plots. Right now I'm on x equals. If I hit enter, look, my y equals switched to x equals. That is awesome. I don't get that option in normal y equals. Now, the only limitation to this is that I can't graph like x equals y squared plus 7 here. The only thing I can graph is constants here. So I can graph, x is greater than 2, or x is equal to 5, or x is less than or equal to 7, but just constants. So I'm going to do x is greater than or equal to 0. And then if I wanted to get back to my y equals screen, I could just come back up here to y and hit enter, and it would switch me back. Okay, so we've got all four of our inequalities in there. Let's go set our window. Now, remember when we graphed this by hand just a couple of minutes ago? You can still see it over here on the board. We were going through, for our x values, we went from 0 to 300. And for our y values, we went from 0 to 250. So I'm going to do the same thing here. I'm going to back up a little bit so that I can see my x and y axes, and I'm going to go negative 25 to 300 instead of 0 to 300, counting by 25s. And I'm going to go negative 25 to 250 instead of 0 to 250, again, counting by 25s. This number that you see up here just affects the shading, so you can play around with that a little bit. You may not want yours on a 6, you may want yours on an 8 or a 9, but just play around and experiment with that and see what your personal preference is. Okay, so Let me go back to y equals for just 1 second. All right, so it's so cool when we graph this because we get to watch it. There it drew the first equation, and then the second one, and then the third one, and then the fourth one. So it's the exact same way that we graph a system of inequalities by hand. We get to watch our calculator come in and draw them one on top of the other. And it does like one horizontal, one vertical, one diagonal one way, and one diagonal the other way, so that we can see where they overlap is my final solution. I can kind of see it because I know, because we just did number 41, I can pick out that region of feasible solutions there, but otherwise I might have a hard time seeing that. It'd be really nice if I could just see where the inequalities intersect. Okay, see this button right here, shades? Shades, if you'll notice, is above F1. So I'm going to hit alpha F1. And I'm going to choose that very first option up there, the Inequalities Intersection. When I do, it will graph those 4 inequalities, but as a new one comes in, it'll erase off anywhere that they don't overlap, so I get a nice clean region of feasible solutions. So there's my first one, but when the second one comes in, it cuts off where they don't overlap. I know, right? I'm a math geek, I know, but that is so cool. All right, so what I'm left with is my bounded region of feasible solutions. All right? As smart as this calculator is, you would think that it would be able to tell me my vertices, right? Well, that is exactly what this is right here. It will tell me the points of intersection. It will allow me to trace them because that vertex right there is just a point of intersection of those two graphs, right? So point of intersection, you'll notice, is really more above F3. So I'm going to do alpha F3, and it automatically starts giving me my vertices. Now, the way that I get my calculator to name all of my vertices of my feasible solution region is a little tricky, okay? I'm going to use my left arrow key. Right now, I'm at 250, 0. That was one of my vertices of the feasible solutions. I'm going to use my left arrow key, and it will go over to 0, 0. I'm going to use my left arrow key again, and it comes over here to 280, 0. Is that a vertex of my feasible solutions?
Not at all.
No. But remember, it's naming for me the points of intersection. Yeah, that was a point of intersection for what I have in Y1 and what I have in Y3, but it is not a vertex for my feasible solution. So I need to be careful. Don't write down everything your calculator gives you. Be sure that you're just pulling off those vertices of our feasible solutions. Now, no matter how many times I sit here and hit that left arrow key, it is only going to give me those 3 points over and over and over again. If you notice up here in the top corner, it'll tell you what it's finding. That's the intersection of Y1 and Y3, intersection of Y1 and Y2, intersection of Y1 and X1. I need it to give me intersections of other things, right? So I'm going to use my up arrow key one time. So I'm going to go up arrow. Nothing happened. Well, look what happens when I hit my left arrow key now. Now when I hit my left arrow key, now I start getting different options, right? I've got 0, 175. I've got 250, 0. And I've got 0, 0. So again, no matter how many times I hit that left arrow key, it's going to keep toggling back and forth. So I'm going to hit my up arrow button again, and then start hitting my left arrow button again, and now it will start giving me different points. And then I'll hit my up arrow button again, and hit my left arrow button again, and it will start giving me different points. So I just have to be a little patient. Eventually it will give me all of the vertices. It just has to go through all of the possible combinations of intersections, okay? So the suggestion here is, once you hit that point of intersection, do left arrow, left arrow, left arrow, left arrow, and as many times as you need to until you've gotten all the points that you can for that one. Then up arrow to get some different possibilities. Left, 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 left until you've gotten everything you need there. up arrow to get some different possibilities, left, 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 until you've gotten everything you need there, and keep doing that process until you get all of the vertices of your feasible solutions. But be careful, because it will give you other vertices as well. Make sure that you don't get ones that are not on your bounded region that we're looking at. Okay, so in your note sheet that I gave you for today, I went through and I took screenshots of that whole process for you so that you would have something to refer back to when you practice this tonight. So let's go through that one more time together. Again, this is number 41 that we did last night by hand. So let's go back and look at it using the calculator only. So the first thing that we had to do was we had to get, we already had the x inequality, but for our other three inequalities, we had to get y alone on one side so we could put it into our calculator. Once you open the inequalities application, it should stay open. You shouldn't need to go open it again. So when I go to y equals, if I will hover over my equal sign, I'll get these other options. So since I wanted to do y is greater than or equal to 0, I'm going to do alpha F5, and it will replace that with greater than or equal to, and it will also know where to shade. So I'm going to do the same thing for my other two y inequalities. Then to put in the x inequality, I'm going to arrow up, so just up, 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 and I'll come up here to x equals and hit enter, and when I do, it switches y equals to x equals. And then I'm able to do the same thing, hover over equals, and choose my inequality symbol that I need and put in my constant. And again, remember that only works for constants. If I want to get back to y, all I have to do is come up here to y equals and hit enter, and it'll switch me back to y equals. All right, so now that I've got all of my inequalities in, we went in and we set our window to be the same as it was when we were graphing this by hand. And so we got our graph. And we were able to watch it come in and graph each of those inequalities one at a time in a different direction, just like we've been doing. We also then were able to get it to just go back and show us the inequalities intersection by choosing shades, which was alpha F1. And then we chose the very first option there, inequalities intersection. And then we were able to see it redraw where all that it left me with was the bounded region of feasible solutions. So then we chose point of intersection trace, which was alpha F3. And we just had to be a little bit patient here. We went through and kind of went to the left to get all of the options that we could. And then we went up and went to the left and got more options. And then we went up and went to the left to get more options until we went all the way around that and got our calculator to give us all of those vertices. Be careful though, because remember, it does also give me other points of intersection that are not vertices. So once I've got my vertices, then I can go back and plug them into my objective function, and that will give me the values that I can see. Okay, my maximum is 11,500, and that's when x equals 200 and y equals 50. All right, so here is your homework for tonight. There's nothing for you to write and turn in, because what I want you to do is redo number 41 last night from scratch on your calculator. So clear everything out of y equals and just start over again and see if you can do that thing in its entirety. The reason that I'm having you do the same problem again is if you get stuck on something, then you've got this note sheet that tells you step by step what to do so it can get you back on track. Okay? So work with that same problem. For your quiz tomorrow, I'll give you a full sheet of graph paper so that you can do it by hand, but you'll also have your graphing calculator in case you would rather do this on the calculator in its entirety. Okay? Same thing with the review homework.